Question number 2 of the PhilNITS FE afternoon portion of the exam. In this question, we are now answering the next sub-question. And to answer this, we'll need to read the descriptions. And I think some of the parts here are already given in the previous sub-question. Because what I do here is I make it a little bit more compact. Because otherwise, it will be too long and we will have to go back and forth several times and it might be too confusing. But if you got the printout, I think you can much faster do it, and I think it should be okay. But in this case, we are using a digital version of the exam, and I've removed some of the parts that are unnecessary for us to answer this question. Now, in this question, what we need to know is the output. Given the present state where we're at and the input, what would be the output? This question actually took me a little longer when I was answering this a while ago because it was about half a year when I was able to answer this, I think. But if you can put in a little bit more time to understand what's going on, what the variables V and Z mean, then I think you should be able to answer this as well. Of course, if you're pressed for time and you're in a hurry, it's likely that you'll have a difficult time getting the right answer because it might be confusing. You're unable to understand what V and Z actually means. Just like a while ago, I was thinking, why do we have V again? Why do we have Z again? And actually, the answer to that is in the table just above this one. The state names and 2-bit state codes. This one tells us that to find out what state we're at, we need to look at the V bit and the Z bit. The V bit would be the one on the left because the state code here has two numbers, right? The V bit would be the one on the left and the Z bit would be the one on the right. We need the state because we need to know where we're starting at. And then from there, given the input, we should be able to find the next state and the output. To explain that a little bit more clearly, we need to go back to the diagram up above here. So if you look at this part on the left, S0 is state 0. So if we know that we're starting at S0 and the input is 0, then we just go back to state 0 with an output that is 0. If our input is 1, then we go to state 1 where the output is 0. Now, if we're starting from S2, state 2, and the input is 0, then the final state would be 0, where the output is 0. If we get 1 as the input, starting at state 2, then the output would be state 2 again with the number 1 as the output signal, okay? Alright, so that's the idea. Now let's look at the table where it's saying here again that to know if we're in state 0, state 1, state 2, we need to look at the V bit and Z bit, okay? The binary coded state transition table tells us that we need to look for the bottom rows, the last two rows here. And it's saying that the present state, current state, has 1 for V and 1 for Z. So they're both 1, 1. And if we look at the table above, 1, 1 for V and Z bits gives us state 2. So we're starting at state 2. And then our input, we got 0 and 1 here. And then we need to know what will be the output, okay? So let's go to the diagram again. We're starting at state 2. If our input is 0, then we go to state 0 where the output is 0. Okay? Now, if we're getting 1 as the input, then we get 1 as the output. And we're still back at state 2. Okay? So if we write that down, the input for 0 gives us 0 as output. And if the input is 1, it gives us 1 as the output. Okay, so I've written it down here. And next, what we need to know, what we need to do is to find which among the answer groups, or the answer, yes, in the answer group would have the 0 and 1. And from here, we find that it's letter B. That's why letter B is the correct answer.